Have you ever wondered when we first realized our planet's climate could change? It wasn't last year, or even last decade. The story of climate change is a scientific detective story stretching back nearly 200 years. It's a tale of brilliant minds, forgotten warnings, and a slow dawning realization that would eventually shake the world. Let us rewind the clock and uncover the hidden history of how we discovered our planet is warming. Our story begins not in a modern lab, but in the 1820s with a French physicist named Joseph Fourier. He was fascinated by a simple question: why is Earth so warm? He knew the sun's energy hit our planet, but by his calculations, that heat should have radiated right back into space, leaving us a frozen ball of ice. Fourier theorized that something in the atmosphere must be trapping the heat, like the glass of a greenhouse. He didn't know what it was, but he had planted the first seed of an idea. Our atmosphere plays a crucial role in regulating Earth's temperature. Decades later, in the 1850s, an American scientist and women's rights activist named Eunice Foote decided to test this theory. In her home lab, she filled glass cylinders with different gases and placed them in the sun. She discovered that the cylinder filled with carbon dioxide got significantly hotter than the one with regular air. In her 1856 paper, she wrote that an atmosphere of that gas would give our Earth a high temperature. It was a groundbreaking discovery, the first experimental proof that CO2 traps heat. Tragically, as a woman in 19th century science, her work was largely overlooked for over 100 years. Just a few years later, across the Atlantic, an Irish physicist named John Tyndall independently conducted more rigorous experiments. He built a sophisticated device to measure how different gases absorb heat radiation. His results confirmed Foote's findings with stunning precision. Carbon dioxide, water vapor, and methane were incredibly effective at trapping heat. Tyndall was the one who firmly established the physical basis of the greenhouse effect. He even speculated that variations in these gases could have caused past ice ages. But here's where the story takes a fascinating turn. For the next few decades, the idea of a warming planet was actually seen as a good thing. In 1896, a celebrated Swedish scientist named Svante Arrhenius decided to calculate the effect of industrial emissions. The Industrial Revolution was in full swing, with factories and chimneys pumping out smoke across Europe and America. Arrhenius, using pen and paper, painstakingly calculated that doubling the amount of CO2 in the atmosphere would raise global temperatures by about 5 to 6 degrees Celsius. He predicted this would take several thousand years, and he thought it would be a wonderful development, leading to better crops and preventing a future ice age. It was a benevolent curiosity, not a threat. For the first half of the 20th century, this idea remained a scientific backwater. Most scientists believed the vast oceans would simply absorb any excess CO2 we produced. The planet was too big, they thought, for tiny humans to have any real impact. This comfortable assumption was shattered in the 1950s by an American oceanographer named Roger Revelle. His research showed that the ocean's surface waters could absorb CO2 nearly as fast as people thought. He famously stated that humanity was conducting a large-scale geophysical experiment with its own planet. The alarm bells were starting to ring, but they were still faint. To prove it, Revelle needed hard data. He hired a young, meticulous geochemist named Charles David Keeling. In 1958, Keeling set up a monitoring station high atop the Mauna Loa volcano in Hawaii, far from the direct pollution of cities and factories. He wanted to get a clean reading of the planet's atmosphere. What he found would become one of the most famous graphs in modern science. The data was unmistakable. Year after year, despite seasonal ups and downs, as plants in the northern hemisphere inhaled CO2 in the spring and exhaled it in the fall, the overall concentration of carbon dioxide was steadily, relentlessly rising. This graph, now known as the Keeling curve, was the smoking gun. It was the first undeniable proof that human activity was changing the chemical composition of our entire atmosphere on a global scale. By the 1970s and 80s, the scientific community was reaching a consensus. More sophisticated computer models were being developed, confirming Arrhenius's basic calculations, but on a much faster, more alarming timescale. Scientists like NASA's James Hansen began to speak out, translating the complex data into a clear warning. In the sweltering summer of 1988, Hansen testified before the U.S. Congress, stating with 99% confidence that the warming trend was not a natural variation. It was happening now, and it was caused by us. The story was no longer a scientific curiosity, it was front-page news. That testimony marked a turning point. Climate change entered the public and political arena, leading to the creation of the Intergovernmental Panel on Climate Change, or IPCC, the same year. The IPCC's job was to synthesize all of the available science and provide clear assessments to the world as governments. Since then, thousands of scientists from around the globe have contributed to its reports, each one adding more certainty and more urgency to the picture painted by Fourier, Foote, Tyndall, and Keeling. From a 19th century thought experiment to a 21st century global crisis, the history of climate change science is a powerful testament to the scientific method. It's a story of connecting dots over generations, of building upon the work of those who came before, and of speaking truth to power, even when the truth is uncomfortable. The science that began with a simple question about why our world is warm has given us the most critical challenge of our time. Understanding this history isn't just about looking back. It's about understanding why we need to act now. Thank you so much for watching. If you found this journey through scientific history interesting, please hit that like button. And subscribe for more deep dives into the stories that shape our world. See you next time.